Alright, so let's go through this Try Yourself 13 2011 physics question. Okay, so the very first part A, right, distinguish between electrical resistance and resistivity. So this one simply just use the definition. So resistance of a component is the ratio of the potential difference across its end and current flowing through it. Okay, what about the resistivity? Okay, resistivity, right, is the constant of proportionality that relates your R with the length to cross-sectional area. So which is just R equal to rho length over area. So this is for the first part A. Okay, let's talk about part B as well. Okay, part B, right, we have a cable made of 24 thin strands of copper wire. So each strand has a diameter of about 0.26 mm. So copper has a resistivity of 1.7 times 10 negative 8. Okay, we are asked to calculate what is the resistance of one strand of wire of 1 meter. So this one you simply just use the formula R equal to rho length over area. So rho is given, right? Then length is 1 meter. Okay, area you need to calculate. Also, of course, just remember to do a bit of conversion. So for example, right, 0.26 mm, you change to meter first. Then for me, I simply use pi r square because it's a cross-sectional area. So you do the calculation, hopefully you'll get about 0.320 ohm. So that is for 1 meter of the copper wire. Okay, so for part 2, what is the total resistance of the cable of length 5 meter? Okay, cable is this whole thing. So for example, you look at this, right? So there are 24 thin strands of copper wire inside this cable. And this cable is 5 meter, not 1 meter. Meaning that for the resistance, right? Okay, we know that 1 meter of copper wire is about 0.32 ohm. So means that you need to times 5 first because it's 5 meter, right? So 5 meter, so you'll get about 1.6 ohm, give or take. Okay, then how do I actually calculate the total resistance? Because you think about this, the copper wire, there's 24 strands. And how are they actually arranged? They're actually arranged in a parallel manner. So means that you just need to do a bit of visualization. You actually notice that it's actually parallel. So you just need to use the formula for the parallel circuit, meaning 1 over R, which is the total resistance, right, is equal to 1 over 1.6 all the way plus until the 24 strand. Meaning I just use 1 over 1.6 times 24. Then of course you get the answer, you remember to flip it up. So this will give you 0.0667. So that is the part 2 total resistance of the cable. Okay, what about the battery? Okay, the part C, right? The battery has an EMF of 12 volts, so negligible internal resistor. So we have a 3 ohm resistor permanently connected to one of the terminal, and of course we have a variable resistor connected in series across it. Okay, the first part, we are asked to calculate the maximum possible current from the supply. So the maximum possible current from the supply is when my big R right here, right, is 0 ohm. So means that R equal to V over I. So my V, right, is it's 12. R is 3. So you do the calculation of apparently, right, my maximum current, right, is about 4 ampere. Okay, what about the part 2, the minimum safe power rating? This one I just simply use power rating, right? So power, P equal to I square R. So 4 square times R is about 48 watts. So that is for the first part. Okay, then of course they say, suggest the purpose of the 3 ohm resistor. So this one is to actually to prevent the overheating of the circuit when the variable resistor R is very, very low, or even go to 0, right? So imagine there's no 3 ohm resistor. So let's just say, okay, I have a battery, I have this variable resistor, then I connect. So imagine, this one is 0 ohm. Then we have a 12 volts battery here. So this will actually cause my current to be very, very high. So it means that it will cause overheating. So that is the purpose of the 3 ohm resistor. Okay, now we go to part D. Okay, part D, we are given a power against your big R graph, right? So this is something that we learned today. So so we are given the power against your R. Okay, then they ask this question. State the 2 values of R such that the power distributed in the variable resistor is about 9 watts. This one is stating, just look at the graph, right? So this is 9 watts. So apparently this is 1 ohm and 9 ohm. so that of course the R big R is 1 ohm or 9 ohm. Okay, then for part 2, we are asked to calculate the efficiency, right? Efficiency very simple. Simply just use power output over power supply. So to keep things simple, your big R, right, is R over R plus small r. Then after that, I'll just sub in. So 1 over 1 plus 3. So it's about 25%. So the efficiency of the circuit, right, is about 25% when the big R is 1 ohm. So of course, for the number 2, the R is 9 ohms, right, the efficiency will be 75%. So you can see that the efficiency actually increase as my big R increase. Okay, the last part. A battery is to be designed to provide the power to a component that has a fixed resistance. So the internal resistance, small r, right, is to be chosen to provide maximum efficiency of the energy transfer to the component. Okay, maximum efficiency, just remember, it's not your maximum power theorem. Because maximum power theorem, remember, is that maximum power theorem just states that if your big R is equal to small r, right, meaning the external resistor is equal to the internal resistor, the power across the external resistor will be equal to maximum. It's not the efficiency. There's a difference, right? Efficiency is the efficiency. For maximum power theorem, right, is the power across your external resistor. Okay, so use your answer in part D to state and explain the choice of small r compared with the component fixed resistor. So okay, of course, the first part, right, so you might be thinking, oh, maybe I can just use the MPT. So for example, right, okay, so I look at here, this one is the answer. Oh, my big R or my big R should be around 3, which is wrong. Because they are asking for efficiency. Unless they ask for maximum power theorem, then you can choose the answer to be 3. Okay, so for the efficiency, just remember is the small r must be as low as possible compared to the fixed resistor, because we must use our answer, right, in part D, because as seen from part D, right, part D number part 2 lah, you can see that as your R is big, right, your efficiency will be greater. So just call. So the efficiency when R is 9 ohm, while small r is 3 ohm, is 75%, while efficiency is only 25% when big R is 1 ohm and small r is 3 ohm. So we conclude is that big R, right, must be as big as possible, while small r must be as small as possible, right, for efficiency to be maximum. Right? So that is how we do this question.